We can map the surface of Mars down to the meter. Yet, if you ask geographers to agree on the basic length of Earth's largest river, they can't give you a straight answer. Depending on which scientific study you consult, the length of the Amazon River swings wildly, from 4,200 kilometers all the way up to over 7,000 kilometers. That is a margin of error roughly equivalent to the entire width of the United States. The measurement debate is just the start of the geographical anomalies. The Amazon commands a staggering network of over 1,100 tributaries, cutting across millions of square kilometers of South America. But across all that flowing water, there are exactly 0 bridges spanning the main river. Then there is its mouth. The river holds an incredible 20% of the world's flowing fresh water, yet when it finally meets the Atlantic Ocean, it completely fails to form a delta, the branching landmass you see at the ocean mouth of almost every other major river on Earth. The shifting measurements, the absent bridges, and the missing delta are the physical results of the river's unique history. The Amazon breaks the rules of cartography because it was formed through geological events that few other rivers have ever experienced. To understand why the Amazon breaks the standard rules of nature, we must rewind the timeline. 67 million years ago, the Proto-Amazon actually flowed in the exact opposite direction. It started in the east and emptied straight into the Pacific Ocean. That path was destroyed when the South American and Nazca tectonic plates collided, forcing the Earth's crust upward to create the Andes mountain range. Suddenly, the river's western exit was sealed shut by an impassable wall of rock. With nowhere to go, the blocked water pooled into a massive inland sea. For millions of years, this trapped ocean sat in the middle of the continent, until the water level grew so high it finally broke through the eastern bedrock, carving a brand new path toward the Atlantic. This chaotic origin explains the missing bridges. Because the Amazon was born from a sprawling inland sea, its main channel is incredibly wide, stretching from 10 kilometers across in the dry season to over 100 kilometers during the floods. You simply cannot engineer a physical bridge across that kind of shifting, massive distance. Instead, millions of people rely entirely on boats and ferries. That uncrossable width is a direct result of ancient tectonic movement. When the continent folded, it trapped all that water, and in doing so, it imprisoned millions of ancient ocean creatures. The transition from a saltwater inlet to a landlocked sea created a massive evolutionary filter. As the salt levels dropped over millions of years, the trapped oceanic species either adapted to the changing chemistry or disappeared. The surviving creatures followed unusual paths. The Amazon river dolphin, or boto, is a descendant of those trapped oceanic ancestors. It lost its ocean-faring traits to navigate shallow, murky river basins. As they age, they lose their original gray color, turning a striking, vivid pink. The enclosed environment pushed other species to extreme sizes. The prehistoric Arapaima evolved to reach lengths of up to 15 feet. Its heavy, armor-like scales are a direct adaptation for surviving in a highly competitive, confined ecosystem. The shallow, muddy edges of this river system created the perfect hunting grounds for ambush predators. Hunters like the massive black caiman and the heavy green anaconda thrived here, utilizing camouflage in the slow-moving, murky water. The biodiversity of the Amazon is the outcome of a geological prison. It forced the creation of an ocean freshwater hybrid ecosystem entirely unique to this region. Knowing how this landscape shifts helps explain why modern cartographers still can't agree on a map. For decades, the Apurimac River was the accepted source of the Amazon. But in 2014, researcher James Contos published a study challenging that, proposing the Mantaro River as the origin point. The disagreement comes down to how we define rivers. Map makers typically define a river's starting point by tracing its longest continuous physical path. Geologists, however, argue the source is the branch that produces the highest volume of water. In the Amazon, seasonal droughts constantly alter the water output of these branches. The Mantaro might pump out the most water for a few months and then dry up. This means the starting point actually shifts depending on the time of year you measure it. And the surface water is only half the story. In 2011, researchers discovered a colossal underground aquatic system flowing 2 miles beneath the Amazon basin. Known as the Hamza River, this flow mirrors the river above, moving through porous bedrock. The Amazon remains unmappable because it is a shifting three-dimensional entity. It alters its origins with the weather, it constantly redefines its borders, and it hides a twin river deep underground. This massive system eventually channels into a single outlet. During peak flood season, the Amazon dumps over 300,000 cubic meters of fresh water into the Atlantic Ocean every single second. That output causes a distinct chemical reaction. The sheer volume of fresh water lowers the acidity and salt content of the ocean surface for miles. It creates a boundary where the lighter river water floats right on top of the heavier seawater. This satellite image shows how that collision happens. The river's output is so massive and the coastal ocean currents are so strong that any sediment pushed out of the river is instantly swept away. That prevents any delta landmasses from ever forming. But the raw power of this system is failing. Decreased rainfall and accelerating human deforestation are disrupting the ancient water cycle that sustains the entire basin. The Amazon has functioned as a self-sustaining engine for 67 million years. Today, as the forest shrinks and the rains fail, its continued existence has become a more pressing concern than its exact geographical source.